Welcome to Marine Basics. I am Marine Engineer Fonseca. Today's main topic will be laws of motion. This topic will not directly related to marine studies, but for anyone who seeks basics of dynamics. I will be discussing basics of matter, important terms of dynamics, Newton's 3 laws of motion, briefly about each law, and equations derived from Newton's law. So let's begin. Have you ever wondered what is an atom? The word atom is a Greek word, meaning that which cannot be split. Around 2500 years ago, Greek philosopher called Democritus stated the atomic theory of the universe. Democritus was thinking and came up with the idea that there must be a point where you could no longer cut something any smaller. But with the time and with the revolution of the technology, scientists found the exact structure of the atom. So, atom is the smallest part of a substance that cannot be broken down chemically. Atom consists of small central nucleus composed of protons and neutrons. If several atoms react with each other and form a stable unity by chemical bonds, these are called molecules. Diagram shows the water molecule. Atoms of different elements have different atomic structures because they contain different number of protons and electrons. This is the reason for the unique characteristics of different elements. Diagram shows different atomic structures. All matter consists of molecules, which includes an atoms, which in turn consist of protons, neutrons and electrons. This shows how to produce matter from atoms and molecules. There are 3 states of matter: solid, liquid and gas. Solid holds the shape of the container and fixed volume. Liquid takes the shape of the container and free surface and fixed volume. Gas takes the shape of the container and volume of the container. Well, the entire system of dynamics based on 3 laws of motion, which are called fundamental laws. These 3 fundamental laws formulated by the famous English mathematician Sir Isaac Newton. Important terms. What is dynamics? Basically, the science of the motion of the bodies called dynamics. Here the body means anything that has a mass and occupied some volume. Force. Any force which produces or tends to produce, stops or tends to stop the motion called force. As you can see, an elephant applying a force to move the timber. On right side, goalkeeper applying a force to stop moving ball. Mass. It is the matter contained in a body. Units are grams, kilogram or ton. Weight. It is the force by which the body is attracted towards the center of the earth. Weight also is a force, so units will also be same as the force. Momentum. It is the quantity of motion possessed by a body equals mass multiplied by velocity. We will discuss the momentum later in this video. Keep watching. Inertia. It is an inherent property of a body which offers resistance to the change of its state of rest or uniform motion. In other words, a property of matter by which it remains at the state of rest or in uniform motion in the same straight line, unless acted upon by external force. Now we will discuss Newton's 3 laws of motion. Number 1. Every body continues in its state of rest or uniform motion in a straight line, unless it is acted upon by some external force. Number 2. The rate of change of momentum is directly proportional to the impressed force and takes place in the same direction in which the force acts. Number 3. To every action, there is always an equal and opposite reaction. Now we will discuss Newton's first law of motion. It is also called the law of inertia and consists of 2 parts. First, a body at rest. Second, a body moving with a uniform velocity in a straight line. You can see in this animation, the ball is at rest, then an external force acted on the ball to change its state, which was at rest. If there is no any external force act on the ball will stay rest at its initial state. And when ball is moving in uniform velocity in a straight line, it will continuously move until it's changed by an external force. Well, Newton mentioned about the steady state. Steady state can be a body or object at a rest or moving in a straight line at a uniform velocity. Newton's second law of motion. We know momentum is equal to mass multiplied by velocity. That means quantity of motion. Now we know momentum is the quantity of motion possessed by a body or object. To further simplify, we will see an example. As the ball rolls the ramp, its momentum increases as it picks up speed. The blue ball at the bottom is stationary until the yellow ball collides with it. During the collision, this momentum is transferred from the rolling object to the stationary object, which will then start to move. The total momentum remains the same after the collision, as momentum is always conserved. But as both balls now have momentum, the object that rolled down the ramp has less momentum than it did before the collision, as some has been transferred to the other ball. Momentum will depend on its mass and velocity. Momentum is always conserved, and momentum is a vector quantity, which means has a direction and a size. Okay, now let's derive an equation from Newton's second law. Well, according to the Newton's second law, it mentioned about the change of momentum. Let's consider about the yellow ball here and consider any 2 points. Initial momentum we will consider as u and final momentum consider as v. Now let's take a look at rate of change of momentum. Force proportional to change of momentum divided by time. When we say the rate of change of momentum, that means the change of momentum per unit time. So according to the Newton's second law, force is equal to rate of change of momentum. This force is force required to change the state of the body. We can see acceleration equals to the rate of change of velocity, and K is equal to the constant of proportionality. Hence, force is equal to the mass multiplied into the acceleration. Let's see another example. Well, a person pulls on a cart of mass m with force F, and as a result, the car accelerates in the direction of the pulling force. If twice the force is applied, the acceleration of the cart is multiplied by 2. If the mass of the cart is multiplied by 2, its acceleration also divided by a factor of 2. Newton's third law. To every action, there is always an equal and opposite reaction. Here, the action means the force. Best illustration to understand this by considering the example of a bullet firing from a gun. Here, according to the Newton's third law, momentum of bullet will equal to the momentum of the gun. So, mass of the gun will multiplied by the velocity equal to mass of the bullet will multiply the velocity of the bullet. This relation is known as law of conservation of momentum. When you understand these basics properly, it will definitely helpful for your future studies. That's it for the day. Hope you have learned something. Please hit the subscribe button for future videos. Share your ideas in the comment section. Stay safe, stay positive, and thank you very much.